I know, that 12, the negative point 4, I can totally right on that.
I'd like to point out that Villanova is so open-minded. I'd like to point out that they're going to get one where I had alphabetical order. But I have more than one. I also have Ohio State lost pretty
You guys can see the screen? Okay. I assume that some of you had a good time during the weekend thinking about making money.
I'm not even sure if I want to show
What we want to do today is start a new section. Okay. However, this section will not be on the exam. I have a handout here. You should pick 2 pages. Okay. What we will start today is basically section 10.1. Section 10.1. Remember, we just finished 7.4. We still have one more section in chapter 7, which is 7.5. But 7.5 is basically a section where you have a bunch of integral problems and they don't tell you what to use. Like if you have a problem in section 7.1, you know that you have to use integration by parts. If you do a problem in section 7.4, you know that you have to use partial fraction decomposition. But in 7.5, it's an exercise with mixed problems, okay? And I will be assigning some problems from there, and you're just going to do them on your own. If you have questions, of course, I will answer, but I'll just be assigning problems from there. But 7.5 will not be on the exam. Okay, I'll be nice, right? No, it's not going to be on the exam, but 7.5 will be on the third exam. So, again, we are going to do section 10.1. I'll be finishing this, but it's not going to be on the exam. So, what is section 10 point about? Oh, before I start that, anyone has any questions? No? Okay. So what's the topic in section 10.1? It's on what we call parameterized curves. So what is it about? So let's suppose a bug is moving in the plane in the plane along a curve, and the curve will then be its path. So the bug is moving along a curve in the plane, and that curve is the path. So let's say the path looks like the following. Whoops. Want a different color. And this is the initial position of the bug. Maybe this is the end position of the bug, and the bug is a red bug. Okay. So here's let's say at time t we have the position function of this bug. So let's say the position of the bug at time t is given by the function r of t. So r of t tells you what are the coordinates of the bug at time t. So r of t will be a point in the plane. So let's say the first coordinate is given by x of t, the second coordinate is given by y sub t, and let's say we are only looking at the time interval between a and b. It doesn't have to be a finite interval, it could be infinite interval, but let's just say that the time interval between a and b. So maybe at time a the bug is at this point, and at time b the bug is at the other end of the curve. And let's say what's the orientation of the path, meaning that in which direction is the bug tracing the curve. Let's say the bug is tracing the curve in this direction. Okay, is that making sense? So even though I'm saying t, the parameter t here represents time, but it doesn't really have to be time. In many applications, t could be something else. So maybe, for example, maybe instead of t being being time, maybe that I am looking at, let's say, let me draw another curve here. So let's say I have another curve here like this, and the position of the bug as a function of the parameter t, maybe t represents this angle here. Okay, so I am telling you the position of the bug as a function of t, where t represents the angle of inclination. Maybe the origin is its home or something. So you're looking at what's the position of the bug when the value of the angle of inclination is this. Okay, so it doesn't have to be time. It could be t, could be some other parameter. Okay, it's not necessarily time, but I find it very useful to think of curves as a position of a moving object. So it's useful to think about t as time. Mathematically, mathematically, what is a curve? What is a curve here? The curve is basically any function out of t. So the function out of t that I have here, that represents a parametric curve. Okay. So for me, the definition of a parametric curve is that it's a function where the input value for the function is the number t, and the output value for the function is the point in the plane. So as t varies from a to b, you look at all the points you obtain from the function, and that gives you a curve. and that's the parametric curve. Okay? And in application, I can think of the parametric curve giving me the path of a moving object. Okay? Now, when my wife saw me writing this bug and so on, she was like, why do people care about bugs? Okay? And so on. And well, you know, but the bug could be a plane, right? The bug could be the satellite or something else, okay? Of course, here we are restricted to 2 dimensions because we only have functions of one variable at our hand. But when you go to calculus 3, you can think about the moving object moving in the space, okay? And in that case, maybe the path looks like this, okay, in space. So my point is that we are restricted here to curves in the plane, but you might have a 3-dimensional curve, right? That is, our curve is lying on a plane, but there might be curves which do not lie on a plane, right? Imagine a 3-dimensional like a coil, right? It's a curve, but it's not in the same plane. The points are not on the same plane. So you can imagine that in that case, you know, you can imagine applications in studying motions of aeroplanes or satellites or many other stuff, okay? Or the motion of planets, for example. In any case, so let's look at a few examples now. Here's my first example. Usually, when you have a curve given by the function out of t, a lot of the time people express the function in the following way. They write c, and then they will write a colon, and then they will write x is x of t, y is y of t, and then they will write t between a and b. Okay? So sometimes people, instead of writing out of t, they will write this. And so c is the curve given by these parametric equations. Here's an example. Let's say I have that x is t squared minus 2t. Oh, you know what? Let me backtrack for a second. I want to write c, and then the curve c is given by t squared minus 2t, and then the second coordinate is given by let's say t plus 1, and let's say the time in this case I am not going to restrict to a finite time interval. Let's say time here is negative infinity to positive infinity. So if I want to think of this as the position of a moving object, then the time here basically past 0 would mean now, and positive values of t would mean future, right? So what's the question is then, sketch the curve, okay? Sketch the curve. Sketch the curve. Well, if you are a machine, what you could do is that you can pick thousands of values of t, right? Pick thousands of values of t, and for each value of t, compute the corresponding point, x and y. Am I making sense? So if t is 0, what do you get? If t is 0, then x is what? 0, y is 1. So you get the point 0, 1. Similarly, if t is something else, you get another point. So if you are a machine, you pick thousands of points, you come up with the points, you plot them, and you get your curve, right? Unfortunately, you are not machine, so let's see how a human will do it, right? So what's the how will I do it? The first step, my first step would be that step 1 would be that I will try to eliminate the parameter t and see if I can come up with an equation involving x and y. Am I making sense? So let's see how we can eliminate t. So eliminate t and obtain an equation in x and y. Let's see if we could do that. Notice that the second equation is what? Y is what? T plus 1. Can I write t in terms of y? What is t in terms of y? T is y minus 1. Very good. So, and now I can plug the value of t in the first equation, right? So if I plug in the value of t in the first equation, what do I get? I get x to be y minus 1 squared minus 2 times y minus 1. And now I could say, I can expand and simplify. So what do I get? I get y squared minus 2y plus a 1 minus 2y here plus a 2, right? So altogether, what am I getting for x then? X is then y squared minus a 4y, right? Plus a 3, am I correct? Okay, so now I have an equation involved. So what we are saying then, what we are saying is the following. If you have a point on the curve, right? So I'm looking at here. If I have a point on this curve, that would mean that x and y are given by whatever the value of t is. I can compute a point, right? So for each value of t, I get a point on the curve. And then we are saying that every point on the curve satisfies this equation. Every point on the curve satisfies this equation, right? Well, that means what? That means the curve is part of the graph of what? So, oops. So I can say, so every point on C satisfies the equation x equals to y squared minus 4y minus 4y plus 3. So C is part of the graph. C is part of the graph of this equation. You guys agree with that? Because every point on the curve C satisfies the equation, so the point has to be on the graph of the equation, right? So whatever the curve is basically part of that equation, right? So all I have to do is come up with now what is the graph of this equation, right? Anyone knows what's the graph of this equation? It's a parabola, and what kind of parabola? What's that? It's turned, like it's like going from, it's opening to the right side, right? And how do I come up with the vertex and so on? You guys remember how to find out the vertex and so on? So basically what you have to do is you have to complete the square. So what I'm going to do, I'm going to look at the first two terms. Say it again.
You said there's a step 1, so would this be step 2? Or is this all still part of step 1?
Oh, we already eliminated, so this would be actually step 2. You're right. I forgot about my steps. This would be step 2. Step 1 was you eliminated the parameter t, and we came up with this equation. Now we graph the equation. So how do we graph this equation? Well, it's a parabola as you said, but what's the vertex and so on? So I can come up with the vertex by saying that, well, this is basically what? How do I complete this square? I don't have the calculator. If you have the calculator, you can easily see what that is. So I can complete this square by doing the following, right? Y squared minus 4y. And then what do I have to add? Remember last time we said something like this? You take half of the coefficient of y, which is 4. Half of 4 is 2. And you square that, you get 4. So you're going to have to add a 4. But since you didn't have 4, you better get rid of that as well. And there was a 3 before as well. So now, with this trick, the first 3 terms can be factored as what? Yeah, it'll be y minus 2 times y minus 2, right, if you FOIL. But then y minus 2 squared is what you get. And here you're getting minus a 1, right? So once you get this, then what is the vertex? Generally, if you have an equation like this, x equals to a times y minus k plus h, okay, y minus k times h. If you have this equation, then this is y minus k squared. If you have an equation like this, the graph is a parabola, and the vertex of the parabola is given by h comma k. Am I making sense? So in our problem then, we have x equals to y minus 2 squared minus a 1. So for us, what's the vertex? The vertex would be negative 1 and positive 2. Remember, in the formula, it's y minus k. So whatever k is, that will be your vertex in the vertex. So let's try to draw this parabola then, if I can. Okay, so to draw the parabola, let's say this is 1 here, this is 2 here. Whoops. What's that? Yeah. Yeah. Okay, so here's 1 and 2. Whoa. Okay, 1 and 2 and 3. The vertex is negative 1, 2, right? So negative 1, let's say, is about here. So negative 1, 2 would be right here about. Okay, so that's the point we get as the vertex. Now, what are the y-intercepts? How do I come up with the y-intercepts? How do I come up with the y-intercepts? Which one is our equation? Our equation is right here, right? How do I find the y-intercept? Replace x by 0. If I replace x by 0, what do I get? Y minus 2 squared is then what? If x is 0 here, then y minus 2 squared has to be 1, right? If y minus 2 squared is 1, then what is y minus 2? Plus or minus 1? Right? If y minus 2 squared is 1, then y minus 2 would be plus 1 or minus 1? Okay, so if y minus 2 is plus 1 or minus 1, what points do you get? So what we are saying here then is x is 0, then you get y minus 2 squared minus a 1. So then I'm saying y minus 2 squared is equal to 1. So that would tell you that y minus 2 is plus 1 or minus 1. When you get plus 1, then the point is what? 3, right? So that you get the point here. and when you get minus 1, then you get 1, right? So you get two intercepts. Now, what is the x-intercept? For x-intercept, it would be easy if we use this one. For x-intercept, you let y to be 0, right? If you let y to be 0, you get 3. So basically, then I get 1, 2, 3. So I get this point here. So what's my parabola then? And something like this, right? Everybody's okay? To find x-intercept, you plug in y to be 0. So I'm looking at this equation here, right? And remember, both of these are equations of the same parabola, right? This one and this one, they are equations of the both are equations of the same parabola. So I am using this for convenience, because if I let y to be 0, obviously x is 0, which is not so obvious right here, right? So you let y to be 0, you get the x-intercept, and that's 3. So we get this parabola here. So now we know that the path of the moving object is, the curve is given by this parabola, right? But the question is, do we get the entire curve? Do we get the entire curve? That's one question. Remember, all I knew was that the curve is part of the parabola. It's some part of the parabola. How do I know it's the entire parabola? How do I know the curve is the entire parabola? And two, how is this curve traced? If this is the position of a moving object, right? I want to know how the object is moving along this curve. That is, how is it tracing the curve? Is it moving in this direction, or is it coming back like this direction? Am I making sense? Did you have a question?
Yeah.
Mm-hmm. Yeah. For the x-intercept, you plug in y to be 0, right? X-intercept means where the graph crosses the x-axis. So you are already plugging in y to be 0, right? So the y coordinate is 0, right? So when I'm trying to find the x-intercept is the point where the graph crosses the x-axis, right? So at that point, y value is 0. So that's why we are plugging in y to be 0. If I plug in y to be 0, I get x to be 3. So the point 30 is the x-intercept. So this is the point 30. That's the x-intercept. Okay, so let's look at the question that I asked. How do I answer that? To answer that question, we are going to go back and look at the functions x and y. So what was x? As a function of t, it was t squared minus 2t, and the function y was t plus 1. Now remember, what was t? T was any real number, right? Now let's look at the behavior of these two functions as functions of t. What do I mean by that? I mean how these functions are increasing and decreasing. So notice what is x prime of t. X prime of t is 2t minus a 2, which is 2 times t minus 1, right? So if I make a number line and then I plot the point where the derivative is 0, the derivative is 0 where? When t is 1, right? Now, what's the sign of the derivative on the left of 1? Right? How do you find where the function is increasing and decreasing? X prime would be negative or positive when t is less than 1? Negative. So here, x prime is negative. here x prime will be positive. So the function x is decreasing here, increasing here, right? I don't have to do the same thing for y because it's pretty clear that y is at what? It's linear, so it's increasing. The slope is positive, so it's increasing everywhere. So let's see how that helps us. Basically, let's figure out at time 1, where is the bug at? What's the position of the bug at time 1? So let's go back to my x and y. When t is 1, right? If I look at here, when t is 1, what is x? When t is 1, x is negative 1, right? And what is y? Y is 2. So that means at time 1, the bug is at the vertex. Right? Everybody is okay with that? Similarly, you can see that you can figure out at what time the bug is at the y-intercepts. So if you look at it, you'll see that you see that this guy would be t equals to 0, and at time 2 it will be at the other intercept. How do I figure that out? Well, I know that x has to be 0 at those points, so I'm trying to figure out for what values of t will x be 0. For what values of t will x be 0? Well, when t is 0 or when t is 2, right? When t is 0 or 2, x is 0. So I know that these 2 points will be traced at time 0 and 2. So is it clear then that as t increases, what is happening? As t increases, the x coordinate is what? As t increases, the x coordinate is decreasing, right? Decreasing all the way up to time 1 to vertex. So isn't it clear that the bug is moving in this direction? As t increases, the x coordinate is decreasing all the way up to negative 1, right? At this point, x value is negative 1. And then as t increases even more, then the x coordinate then starts to increase, right? So I know this is how the bug is tracing the curve. This arrow that I gave you, this arrow is called the orientation of the curve. Orientation of the curve. So let me write down here for a second the word orientation so that you don't forget. Orientation. How the curve is traced as t increases. Am I making sense? So by orientation means you have to answer this question: how the curve is traced as the value of t increases. As time progresses, how the object is moving along the curve. Okay, that's the orientation. Everybody is clear on what we did? Is that clear how I came up with the curve, the graph of the curve, and then orientation of the curve? Any questions on that? Oh, by the way, you might ask, hey, how do you know you're getting all the points on the curve, right? Did I answer that yet? Can someone tell me why do I get the entire curve? How do I know I get the entire curve as the trace of the object? Yeah, so when t goes from negative infinity to 1, the x value, remember x is a function of t, right? So when t goes from negative infinity up to 1, x value comes from positive infinity, right? And comes to negative 1. Am I making sense? So what I'm saying then is by looking at the graph of the formula for x, which is t squared minus 2t, I know that as t goes from negative infinity to 1, x decreases from positive infinity to negative 1. Okay? And then what is happening to x? As t increases from 1 to infinity, x increases from negative 1 to infinity again. So again, the graph is this. As t increases from negative infinity to 1, x value comes from positive infinity, and then it decreases to negative 1, and then the x value increases again. Is that making sense? Questions on that? All right, so that's just one example. Let's look at other examples, okay? Any questions? If you have any questions, please go ahead and ask. Yeah.
Talking about a bug using
Yeah.
time, are we really ever going to have anything less than 0?
Having anything less than 0?
X can't really have.
Well, I mean, it's like saying that the bug started moving in 1977, and then
We're just putting
today
zero.
is, let's say, time 0, and so on. But I mean, I am using the bug as an example to sort of give some intuition about the curves. Okay? If you have a curve, it's useful to think about a curve as the trace of a moving object. And it's helpful to think about it that way for various reasons. I'll explain more as we go through the examples. So let's look at another example here. And in this example, we are going to make things a little bit difficult. Let's say x is, let's say, given by cosine of t. And then y is given by sine t. Y is given by sine t. And let's say t is between 0 and 2 pi. Okay? Again, the question is sketch the curve. Sketch the curve. How do I do this? Again, what was my step 1? What's step 1? T disappear, right? Make t disappear. How do I accomplish that here? In the first example, we were lucky that I can solve for t in terms of y, and then I plug that value in the equation for x. But in this case, I have cosine t and sine t. What's going to happen if I say t is sine inverse of y and plug that in here? Doesn't really say what the curve is, right? Okay. Anyone else? Yeah. Did you have? Yeah. No. Any others? We are trying to eliminate t, and my question is, how do I eliminate t? How about? Can someone tell me can someone answer the following question? If I have x squared, if I look at x squared and add to y squared, what do I get? What's that? I get 1, right? So notice that what I get is cosine squared t plus sine squared t, and we know from Pythagoras this is 1, right? So the equation that we are getting between x and y is x squared plus y squared is 1. And do we know what that is? It's a circle of radius 1 centered at the origin, right? So I guess what we get then is a circle, and the center is, let's say, right about here. So this is the circle of radius. So this number here would be 1, right? Because it's a circle of radius 1. This number here would be also 1, right? Oops. This number here would be also 1. It's not allowing me to trace too many times. Okay, this is 1 as well. And so this is a circle of radius 1 centered at the origin. So this is 0, 0. However, the question is, do I get all the points on the circle? How do I know I get all the points on the circle? And that's one question. The other question is, how is it traced? If I think of x and y as the position of a moving object, right? Then the question is, how is it traced? What's the orientation? Yeah.
What was your first question? What does that mean?
Which one again?
Have all of the points.
Oh, basically, so at this point we are saying that if x and y lies on this curve, then x and y satisfy this equation. That's all we are saying. If xy is on this curve, then xy is on this curve. That doesn't mean that every single point on the circle is part of the curve. All we know, all the points on the curve are on the circle, but we don't know the other way. Okay. So the question is, how do I know it? How do I know that's the case? And then the question is orientation, right? So how do I figure that out? Say it again. Difference equation? Oh, you're talking about derivative, right? How do you trace the curve? Yes. Like. Subtract it from 0, 0. I think you're thinking in terms of physics. Is that it? No. The way. Okay. So here's how I'm going to answer it. Okay. I think he's thinking. He's probably, I think, thinking in terms of vectors, right? You're thinking about it in terms of vectors, I think. Yeah. We are not going to think about it in terms of vectors, okay? You're basically saying if you have a vector like this and like this, then you're looking at the difference of the two vectors. Probably. Did I say it was a ladybug? I didn't say that.
It was a red bug. So I think it was a ladybug.
All right, so here's I didn't say that. Okay, so here's how we are going to look at the orientation. Okay, so what's the orientation? Orientation. There is actually a easy explanation, but I'm going to give you the hard explanation first. The reason is in general, I want to tell you how to decide that in general, and then for specific problems there are always easier tricks, right? So here's the general way. Remember what was x? Cosine t, and y is sine t, right? And t is between 0 and 2 pi. So let's figure out how x and y are changing. So here's, let's say, 0, and here's, let's say, 2 pi. So in the middle I'm going to have pi. Right here I have pi over 2. Here I have 3 pi over 2. And I want to figure out how x and y are increasing and decreasing. as t progresses. Now, can someone tell me what is happening to x first? X is the graph of cosine, right? So think about the graph of cosine. Cosine at 0 is what? 1. At pi over 2 it's 0, right? So it's decreasing, right? X is decreasing up to pi over 2. And then what's happening? No? It's still decreasing to up to this point, right? And then it keeps increasing to 0 here, and then it goes up here, right? So right here x value is what? 1. And right here x value is 0. Right here x value would be -1. Here x value is 0 again. Here x value is 1 again, right? Well, let's figure out what is happening to y, right? So y at time, what is happening to y? So what's the value of y at time 0? So let's write y here. So y is 0 at this point. And then is it increasing up to pi over 2? Okay, it is increasing up to pi over 2. And at pi over 2, what's the y value? Y value is 1. And then between pi over 2 and pi, it is decreasing, in fact. So let me use like this. Oops. So it's decreasing, and so y value here would be 0. And then it is decreasing, in fact, right? It is decreasing even more to what? -1. And then it is increasing to 0 again. So my point is then, look at the circle. At time 0, it's at this point here, right? At time 0, because cosine 0 is 1, sine 0 is 0. So 1, 0 is the initial position at time 0. So how is the curve traced? Notice that as t goes from 0 to pi over 2, the x value goes from 1 to 0. The y value goes from 0 to 1. So I know that it's tracing this way, right? But if you go through this, as t goes from pi over 2 to pi, then it's coming from this point to this point here, right? So at time t equals to pi, it's right here. And then at time t equals to 3 pi over 2, it's going to come back here. And then at time 2 pi, it's coming back to the initial point. Is that making sense? So I got the entire circle exactly once, and I am tracing it what? Counterclockwise. So the orientation is orientation is counterclockwise. Are we okay with that? Now, before you leave, let me just ask you a quick question. Here's my curve, right? If I replace t here by 2t, what would be the curve? If I replace t by 2t here, what is the difference? What's that? Did you say something? What's the difference? What curve do I get? If I have 2t here instead of t, what curve do I get? Do I still get the circle? Yeah, because I still get x squared plus y squared is 1. What's that? No, radius is still 1. What happens is that it's tracing the curve how many times? Twice. Because as t goes from 0 to 2 pi, 2t goes from what? The angle 2t will go from 0 to 4 pi. You're going to trace the circle twice. In physics, what do you call 2? In physics, what do you call, if I put a 2 here, in physics, what do you call 2? What's that? 2 is the frequency, right? It's the number of times, revolutions per second. Revolutions per second, okay? All right, we will finish this next time, okay? Yeah.
Is that why, like, we measure angles counterclockwise? Because of that?
No, I mean counterclockwise is taken to be positive values. That's just a choice.
Okay.
Yeah. One thing I could have done this much easier because the points, you can think of the T as angle.
Okay. Yeah, well,
Am I making sense?
yeah, no, that makes sense.
See, if I have the circle like this, right? The points are cosine T, sine T. So this is X, this is Y, right?
Yes, sir.
So if this is the point, then we know that what is that angle? That angle is T, right? So in fact, I know that as T goes from 0 to 2 pi, I'm getting the circle. Great sheet. Yeah.